Hello everybody, this is Dr. Kevin Connors giving you another video in our series of understanding gene testing, why we would do it, and what we're looking for. So trying to keep these simple and short, so bear with me, and uh, we're going to go back to Biology 101 here though. What is a SNP? What is a SNP? What are we looking for when we do a genetic test? A SNP defect is a single nucleotide polymorphism. That's when one gene is changed. One little nucleotide on a gene is changed. And remember, when we're looking at genes, you get one from your mom and one from your dad. And you remember this chart from biology, where this is a recessive eye color gene example here. The mother is recessive for brown eyes. The father is recessive for brown eyes. So they have a large B, little b. Everybody's genes have two alleles. So they're dominant B and a small b, the recessive trait. And so the child has a 25% chance of actually being dominant for brown eyes, or a positive for brown eyes, or in this case large B for brown eyes. And they have a 50% chance of being the exact same as mom and dad, having uh, uh, dominant for brown eyes and a recessive for blue, dominant for brown eyes, recessive for blue, and thereby having brown eyes. But they have a 25% chance of being small b, or having blue eyes in this case. When we're talking about gene defects, we're not talking about brown eyes or blue eyes. We're talking about the gene itself, whether that allele is a positive or a positive negative or a negative negative. Well, the wild form of the gene in the case of looking at defects is a negative negative. That's what you want to have. You don't have any defects. If you have a positive negative, that means you do have a defect. It may not cause any problems, remember, but it is a defect and it can cause problems. If you have a positive, that means you have a double allele defect, and that you have a greater chance of it causing problems. And if it does cause problems, it will certainly, can be worse than having none at all. So this is an example of a pathway that we might look at. There's multiple different pathways. This is the folate and the methionine pathway. And each gene is at that arrow. If you see in the center of my slide there's an arrow pointing to a little bubble that says CBS. That CBS is a gene, and that would be one. Every one of these bubbles is a gene that we're looking at, and this is just one little pathway that we look at when we do a 23andMe test and look at all the different genes. And then we look at whether that's a positive negative or a positive positive, or hopefully a negative negative, and will cause less problems. Well, each one of those bubbles is a gene, and a gene makes an enzyme usually, and that enzyme creates a function within the body. So you start with a substrate, meaning a chemical compound prior to that gene, and when it interacts with that gene enzyme, you end up with an end product. Now there's things that will increase the activity on the left of your slide, things that will decrease that activity, and that enzyme needs cofactors, so different nutrients or minerals or something that will help push that gene. So things that could increase that activity could be positive, a good thing, or it could be a negative if you don't want to be making too much end product. Things that decrease that activity usually are a negative. They're blocking that gene function. And it could be a positive, meaning it's a negative feedback loop that's slowing down that gene function because we got too much end product right now. So that's really what we're looking at when we look at these gene pathways. So here would be an example. This is the chiurin pathway, where tryptophan, my circled green circle there, is the substrate in this pathway. Normally tryptophan goes on to make serotonin, but this is what I call a tryptophan steal, where it gets stolen away to go to the IDO1 pathway, that IDO1 gene there. So this is where it gets taken. Tryptophan gets stolen, so it can't create the serotonin that we want to go on to create melatonin to help you fall asleep, or to use as serotonin in your brain neurotransmitter pathways to help calm you and keep you happy. It gets stolen instead down this chiurin pathway, and you see the yellowish, orangish colored things there. The INF gamma, the LPS, the stress, and the TNF alpha. Well, the INF gamma, LPS, and the TNF alpha are basically inflammatory markers, LPS lipopolysaccharides from Lyme and bacteria and such. And stress itself, just emotional, physical, whatever kind of stress that you're dealing with, can push it down this pathway. Well, that's not good because the end product is it makes quinolinic acid, which is an excitotoxin to the brain. It causes all sorts of problems. We don't want to go this pathway. But in the presence of stress and things, it pushes tryptophan. It steals tryptophan and pushes it down this pathway. Now, in the purple there it says calm, IL-4, IL-10, those are calming, decrease inflammation. Those are Th2 cytokines. With a lack of stress, it helps slow that pathway. And that's what we're looking at. So this would force it this way, create more kyurenine, go down to quinolinic acid, and cause issues. And these are things that increase that activity. So if we don't want a tryptophan steal, we want to stay away from stress and stay away from inflammatory conditions. And these are things that decrease that activity. We're going to calm down, decrease our inflammation. But when we are struggling with a chronic inflammatory source, some chronic infection or something like that, well, this is why we have problems. We aren't happy, we can't go to sleep, we're restless, we're all sorts of neurotransmitter imbalances and brain imbalances because these are the kind of things that are taking place. This is why we look at genes. So it gives us some answers of why we have problems. So again, in summary, genes are things that take substance A and turn it into substance B. Now, if there's a defect in that gene, a single nucleotide polymorphism, either positive negative or positive positive, which would be worse, then that gene is not going to work very well. So substance A is not going to move to substance B very well. Plus, if you have things in the purple that decrease that activity, like chronic infections or heavy metal toxicities or a very stressful lifestyle, even if you didn't have the defect, substance A moves to substance B more slowly, and that could cause problems. When your whole purpose of intercellular function is to change different chemicals from one substrate to another so that your body can make energy, so your body can make neurotransmitters, make hormones, detoxify things, etc. It's really important to have these genes functioning correctly. So if we measure, does this person have these gene defects or these single nucleotide polymorphisms, these SNPs, then we can look at, okay, how can we effectively help this person? Can we decrease the things that decrease the activity? Can we increase the things that increase the activity? Can we help with increasing cofactors? There's some different nutritional and lifestyle things that we can change, and we can really change the outcome. Understand it's a process and it takes time, but it works. So that's why we do what we do. If you have any questions, make sure you call our office. I hope this explained some things. And keep watching the rest of our videos. Go to our office website. If you're watching this on YouTube, we got a ton of videos on our website too. Thanks much. Bye-bye.